us using the calculator. Okay, so today, just for this intro warm-up, we've been looking at a normal distribution. We come up with the values along the bottom of our graph. And there's a problem though, because right now we can only find out the percentage or probability of data falling between values that are exactly showing up on our bell curve. But what if we're interested in values that are somewhere in between here, right? So let's say from here to here, like what percentage is going to be in between? Like if you were to slice it like this, right? Like percentage in between, like how do we do that? And that's when we're going to use our calculator. Our calculator is going to be able to do that exactly, okay? You can do a start and a stop, or find out how much is the percentage from here, let's say, to the left, or from here above, and so forth. This is a bit of an estimation tool that we're using, but the calculator will be much, much more precise. So on page 25, we started to look at the average height of males. We figured out that the mean is 177, and the standard deviation was 2.5, okay? And we also put the z-scores at the bottom here. Last lesson, we looked at formulas, right? So this is the formula that you will use to calculate a z-score, okay? That one right there. You need the mean, you need the standard deviation, and you need that score that you want the z-score for. And I also talked about that every actual value has a corresponding z-score that goes with it, okay? And that the z-score tells us two things. The z-score will tell us, like if it's whether it's negative or positive, we know that it's either the fact that you're above the mean or below the mean. That's what the sign tells us. And the number tells us how many standard deviations above or below are you if you have a certain height, let's say, right? So if I said, hey, my height is 174.5 centimeters, and that corresponds to a z-score of -1, then I know you should be able to pick up, it's like, okay, that means that you're below the average, and you're one standard deviation below the average, which kind of tells us that you're not too far away from the average, right? And so that's one thing so my height, for example, I'm 6'5". So that's, I think, 196 centimeters. So where would I be on this graph? 196. I'm not even here, right? I would be like in this tail somewhere here, okay? What's my z-score going to be? It's going to be +3 point something, right? It's going to be well above the average, right? And so that's kind of a z-score kind of tells us how far away above or below from the mean are you with that particular height in this case. It could be weight, it could be IQ score, you name it. Okay, so let's continue. We went through several examples, and I'm just going to finish this page so that you have it in your notes. And then we're going to start using the calculator later on. So here you're asked, what percentage of males have heights with a z-score between -2 and -1? Okay, so I'm going to ask you, I'm constantly going to go back to the graph for now. So between -2 and -1, there's the z-score, right? Even if you didn't have the z-scores written down, you would want to do it at this point. So -2 corresponds to a height of 172, right? So this is our start line. That's where we're going to start counting all the way to +1, a z-score of +1. So we are basically in between these two lines. So we're going to add up all these percentages right there. So that's what I'm going to do here. 13.5% plus 34% plus 34%. And that adds up to 81.5%. And I wanna say this, okay? Asking for percentage between heights of the height that corresponds with -2 is 172 centimeters. And +1 is 179.5. Okay, oops, was off script there. But this is what this question is also asking, okay, at the same time. So you have to know this. Every z-score will have a corresponding actual value attached to it, okay? And I'll tell you a little bit more why we use z-scores sometimes instead of the actual height. It has more to do with standardizing things, okay? And I will show you that a little later. For now, you just need to know that z-scores are a thing and that we can use them, okay? What is the range of heights? The range of heights that would have 95% of males comprised in it. We already answered this one, okay? But we know, this is what I want you to know, okay? That the first chunk is 68, okay? Then we've got 95. And the next one is 99.7. But what we know is that if it's 95 from here to here, we slice this up here, we're talking 2 standard deviations here, so we want this end here, and we want this end here. So we're basically talking about the middle 95, right? The middle 95. And so if we go to our graph, this is 172, and this one on this end here is 182. So this is the range of heights. So 172 centimeters to 182 centimeters. I know that you might say, but Mr. Erickson, like the range, wasn't it like subtracting? Isn't the range 10? Yes, if I ask you to find the mean, median, mode, and range, like in that situation, it's different. Here we're talking about a bell curve, a normal distribution, so this is what we're referring to here, okay? Next, the mean height of females is 162 centimeters, 0.5, right? Standard deviation of 3. Sketch both curves. This is one thing that I talked about yesterday, okay? Sketch both curves on the same plane. How will they differ? Use different colors or patterns to illustrate the differences. So what I'm asking you to do here is a sketch, okay? So I'm going to make my line. Okay, use the space. These will be the heights, the height in centimeters that we're comparing, okay? And how about we quickly do a little chart on the side here, the mean and the standard deviation. We have males and we've got females. Do this on the side here. I think this helps. The average height for males is 177 with a standard deviation of 2.5, right? And the females right here, we're given the information, it's 162.5 and 3, okay? So you're doing a little inventory on the side. And then just ask yourself, right, in terms of the mean, which one is going to be higher up? Because the mean tells us where the peak is, right? Males are higher up along the, so we will put 177 here, and 162 would be here. This is not to scale, it's just a sketch, okay? So males on average are taller. What about the standard deviation? What do we know? Males, which one will be steeper between these two? The males will be, the curve will be steeper because the standard deviation is smaller. So we just go to the 177 and we just make that peak a little higher. then the ones for the females. That's all you have to do. And then just draw your curve. So we're going to go solid for one of them. I use female, will be solid. And then males will be going like this. Okay, so you just do a legend here. So if you can wrap your head around that, because the bigger your standard deviation, the flatter your curve is compared to the other, okay? If you want a different color, you throw that in there, okay? Next, calculate the z-score. So calculate the z-score of a male with a height of 181 centimeters. Okay, so that's when you use this one. I'm going to give you some time in a bit to add this to your study sheet. And we're going to do a study sheet entry with that. So basically, X is the value that you're finding the z-score for. You subtract 177 from it, and you divide it by the standard deviation. These two, if you subtract them, you get 4 divided by 2.5. That gives us positive 1.6. Yes, it's a decimal. You do get decimals, okay? I know that when we label it on the axes, we only go whole numbers. But what does that tell us? Okay? The positive tells us that this height is above the mean. It's going to be a little cramped, sorry about that. The 1.6, let's put that in quotation marks. The 1.6 itself tells us that it's 1.6 standard deviations above the mean. Okay? It tells us basically how far away from the mean are you, right? How many standard deviations. Okay, so there's basically two things that a z-score tells us, and it's actually right under the z-score. If you box that in, I tell you that there. Let's go the other way. Determine the height of a male that would have a z-score of negative 0.4. Right away you can tell that the negative means that whatever height you're going to calculate, listen to this part, is going to be less than 177 centimeters. Okay? Because 177 is your average. Negative means you're below. And the 0.4 is like you're not that far away from the average, but you are below. So we use this formula right here. Okay, use that one. So the z is negative 0.4, standard deviation is 2.5, and the average is 177. If you multiply these two, you get negative 1 plus 177. So this gives you 176 centimeters. And I'll make a little arrow here. Negative is below average. Below the mean. Okay. Okay. So I'm going to stop here.